Alright, so welcome to the third video of Advanced Higher Maths. In this video, we will be covering how to differentiate inverse functions. Now, what is an inverse function, first of all? You should know this. So, let's say we have a function f of x equals y, okay? Y equals f of x, whatever. Well then, inverse, so -1 is a symbol for inverse. It does not mean to the power of -1, okay? It doesn't mean like 1 over f of x. It means inverse f of x, and this is how it's defined. Then, inverse, f inverse of y is equal to x. So this is a definition. If f of x equals y, then inverse f of y equals x. So it's basically the opposite. You're reversing the machine. So how I think about it is, imagine you had a machine, right? This is a function machine, and you do something to it to get a new number out, right? And this is a new number, so it's being split out. This is x you're putting in, some process is happening, and you're getting a y out. Well then, if you're doing f inverse, right, this is f of x, and now if we make a new machine, f inverse of x, well, if we put this y here, we put it in the entrance here. Sorry, I forgot to put my little entrance symbol here. And we have the process. Well then, it's going to spit back out x. So another way to define it is the fact that f inverse of f of x is equal to x. Because f of x is equal to y, then f inverse of y is equal to x. So that's another way to define it. Now, the general method that's used to find the derivative of an inverse function is to start with y equals f inverse of x, because this will be like your function. Often this will be a trigonometric function, so for example cos inverse, sine inverse, or tan inverse. In fact, I think with advanced higher it's always a trigonometric function. It's just good to know the general way of finding it. Then this means that x is equal to f of y from our definition. In fact, we can see it already here. Thus, dx over dy equals f prime of y. Now you'll see something quite funny here. It's dx over dy, and you've probably always seen it so far as dy over dx, but now it's a different way around. But this is no problem, because now it's actually extremely simple to make it the right way around, because we just make 1 over dx over dy. We take the reciprocal, so dy over dx is equal to 1 over f prime of y. Now this isn't a good answer because it includes y in the answer, right? And we want it to be a function of x. So then we go back to our original equation and we try and simplify it further. So then try to simplify to include only x. So we'll look at an example. Like I said, in advanced higher, you only need the inverse trigonometric functions, that is sine inverse of x, cosine inverse of x, and tangent inverse of x. And the great thing is that their derivatives are in the data booklet. However, it's still nice to know roughly how to figure them out, how to derive them. So I'll go through one of them. I'll go through how to derive sine inverse of x, and then if you want to, you can go through the rest on your own. They use pretty similar methods. So let's say we have the function then, y equals sine inverse of x. Remember, sine with a -1 here does not mean sine to the -1. Sine of x to the power of -1. So this here would be equal to 1 over sine of x, but this is not equal to this. So yeah, not this. Y equals sine inverse of x. Well then we can write that x equals sine of y. Now this means that dx over dy is equal to, well, what's it equal to? It's simply equal to cos of y, right? And now we can take the reciprocal to get that dy over dx is equal to 1 over cos of y. So now we've arrived at this step here, right? dy over dx is equal to 1 over f prime of y. But we've got y in the answer and it's not very nice. Thus, we need to go back 1 or 2 steps to figure out how we can simplify this. So let's think about our identity. Cos squared of y plus sine squared y is equal to, well, it's equal to 1, right, from trigonometric identities. So this means we can rearrange this for sine of y is equal to square root of 1 minus cos squared y, okay? Do you agree? Do you understand how we go from here to here, right? So we take away cos squared from both sides, then we square root it, so we get that sine y is equal to square root of 1 minus cosine squared of y. So, sine y is x, right? So this means that x, in fact, sorry, that's not what we're meant to do. It's meant to go to cos of y. We need to rearrange for cos of y. So cos of y is equal to 1 square root of 1 minus sine squared of y in a similar manner to above. And so now what we can do is we know that this is actually also equal to 1 divided by square root of 1 minus sine squared y. But this still includes y. Whatever are we going to do? Well, thankfully, we know that x is equal to sine of y. So this sine of y, sine squared of y, we can replace for x squared. So square root of 1 minus 1 over square root of 1 minus x squared. So this is, so the derivative, d over dx, derivative of sine inverse of x is equal to 1 over square root of 1 minus x squared. That's quite a nice result in my opinion. I find it's very clean, and you can find very similar results for cos inverse and tan inverse, but I'm just going to tell you them for now, and remember that they are in the data booklet. So this is d over dx sine inverse, and here d over dx of cos inverse of x is equal to negative 1, sorry, not negative 1, negative 1 here, it is negative 1, but just above, square root of 1 minus x squared, and then d over dx tan of x is equal to 1 over 1 plus x squared. So very interesting results here, and we can similarly apply the rules that we've learned before, for example the product rule, to some equations involving inverse trigonometric functions. Sorry, that's maybe tan inverse, sorry. So for example, if we had, let's look at a problem, an example problem. If we were told that f of x is equal to sine inverse of 5x, then what is f prime of x? Pause the video and try it out yourself. Now, quite an important thing is to note that you don't need to derive the equation every time you use it, of course. Always just use the value you're given in the data booklet. There's no need to figure it out yourself every time. Also, if you really want to, you can. I won't tell you not, absolutely not to derive it every time, if really you want to. But whatever. So, first step is to name u and v. So u equals sine inverse of x, v equals 5x, u prime equals, well, we have our derivative of sine inverse, it's right here, and we derive this one, 1 over square root of 1 minus x squared, and then v prime is equal to 5. So then this means, as f prime of x is going to be equal to u prime of v times v prime, so this is equal to, so u prime 1 over square root of 1 minus, and then we swap x for whatever's going in the function, which is v, so 5x squared, and then it's times v prime, so times 5, which is equal to 5 divided by square root of 1 minus 25x squared. So we'll go through one last problem. Do try this one on your own. It is good, and this one's going to practice a lot as well for the past lessons, quotient rule, etc. Well, not quotient rule, but lots of other rules. So let's say y is equal to x cos inverse of x over 2. Then what is the derivative of y with respect to x? This one is quite a bit longer problem, but it's definitely worth attempting yourself as a good recap, in fact, of what we've learned up to here. Alright, so let's start by naming our u and our v, so we can see that this is going to be product rule in the end, so u equals x, v equals cos inverse of x over 2. Alright, now u prime is easy, u prime is equal to 1, v prime will take a bit more work, so let's look at v prime. Let's try and do it here. So, v is equal to cos inverse of x over 2. Now we can see that this is just chain rule, right? So we're going to name this q, we're going to name this r, so q equals cos inverse of x, r equals x over 2, q prime, so the derivative of cos inverse is minus 1 over square root 1 minus x squared, and r prime is equal to 1 over 2. And now, just chain rule, we apply the chain rule, so v prime is equal to u prime of v times v prime, which is equal to, see, this is mistakes you need to avoid, which I'm currently not managing to avoid, q prime of r times, oh my god, what am I doing, times r prime. So symbols get messy, as I've discovered. So you need to make sure you're always using the right letters, right positions. Yeah, so q prime minus 1 over square root 1 minus, so x, x is being replaced for r, x over 2 squared, times r prime, which is 1 over 2, which is equal to minus 1 divided by 2 square roots 1 minus x squared over 4, because x over 2 squared, the squared should be bigger here. Alright, so that's only v prime, so we still have steps left to do. So v prime is equal to minus 1 over 2 square roots 1 minus x squared over 4. Alright, and now I'm going to need to turn over a page, unless I can fit it in here. Maybe I can try. So dy over dx is equal to u prime v plus uv prime, which is equal to, so u prime is simply 1, thankfully, so times v is cos inverse of x over 2, plus uv prime, which is going to be negative x over, I'm going to run out of space, 2 square roots 1 minus x squared over 4, which is equal to cos inverse of x over 2 minus x over 2 square root of 1 minus x squared over 4. Now, this can be simplified to include the 2 in the square root, which means it's equal to cos inverse of x over 2 minus x over square root of 4 minus x squared. Don't worry if you don't understand the last step of simplification. So we're putting this 2 inside the square root. So 2 is equal to root 4. So root 4 times root of 1 minus x squared over 4 is equal to square root of 4 times 1 minus 4x squared over 4, which is equal to this bit here. This is our final answer right there. That's quite a long problem, but it's definitely worth practicing longer problems like this. The good thing about differentiation, well, there's lots of good things about differentiation, but one of them is the fact it's easy to create problems for yourself. Just throw in a random bunch of hard functions, maybe in quotient, needing the quotient rule, product rule, both of them, chain rule, and try and mix it up a bit, and try and make them as longer and longer, so you get more and more of a challenge. See you in the next video.